Hello, I am Lütfü Kızıloğlu, computer science sophomore at Bilkent University. For my Physics 101 project, I set up a set of experiments to calculate the spring constant. I designed two experiments and calculated the spring constant using two different methods. This way I could compare the results and have a confidence in my measurements. The two results also allowed me to make error analysis.
In the experiment, I used a variety of tools, including a spring, masses of known value, a stopwatch, a stand and a clamp, an airtable, and a spark timer.
In the first experiment, we used the oscillatory motion of the spring to calculate the spring constant. First, we attached different masses to a spring and measured the period of oscillation. The period t relates to the spring constant through the formula k equals m times 2 pi over t squared, where m stands for the mass, t stands for the period, and k stands for the spring constant. We recorded the time for 10 oscillations for different masses and calculated the spring constant k. For example, with a mass of 320 grams, the average period was 0.253 seconds, leading to a calculated K of about 197.4 newtons per meter. The second method involved compressing the spring with an object moving on an airtable to reduce friction. We measured the puck's velocity and the spring's compression to apply the energy conservation formula. 1/2 times m times v squared equals 1/2 times k times x squared, where m stands for the mass of the puck, v stands for the velocity of the puck, k stands for the spring constant, and x stands for the maximum compression of the spring. By analyzing the puck's speed and the spring compression, we calculated the spring constant. For a 320-gram puck, the average K was about 203 newtons per meter. Both methods gave consistent results, with the spring constant averaging around 204 newtons per meter. The difference between the two methods was about 1.8%, indicating strong agreement and reliability in our findings. This experiment demonstrates the value of using multiple approaches to verify results in physics.